Okay, so here it says consider the hypothesis shown below. So here's your hypothesis. The null is that the mean is less than or equal to 42, and the alternate hypothesis is that the mean is greater than 42. So your null hypothesis will always have an equal to sign in it, and we're making an assumption about the population. So here we're making an assumption about the population mean. And we're giving the sample mean, the population standard deviation, we're given n, and we are given alpha. Now, if it says less than or equal to, or greater than or equal to, then we know that this is going to be a one-tail test, okay? So the alternate is greater than 42. So let me show you how to put that on your distribution curve here. So what I'm saying is 42 is going to be over here. So anything greater than 42, or anything in this area over here, the greater than tail, is going to be what we call our rejection area. Alright, so I'm going to first figure out all of my information, my test statistic, which we're going to get from the formula. So that's what we're going to have to try to find. I'll erase that for now. So first let's find the sample mean. So if we look at our information given, the sample mean is 44. X bar is 44. Then the mean of the sampling distribution, which is assumed to be true for the null. So the mean of the sampling distribution, what we're testing here. So we're testing that the mean is 42. So our value is 42 for that. The standard deviation of the population, which is given to you, it is 13. Then n, your sample size, our sample size here is 38. And again, all this information is given to you. Okay, and then I think we're ready to plug in for our formula. So our test statistic for our sample is going to be, and I'm just going to go ahead and plug in the numbers. We have the formula over here. Do y'all see the formula here? So X bar, which is the sample mean, is 44 minus the mean of the sampling distribution, which was 42, divided by the standard deviation, which is 13, over the square root of n, which is 38. So 44 minus 42. What I'm going to do is go ahead and just down here, I'm going to put 44 minus 42, I'm going to use this calculator, divided by the square root of, what was that again? The square root of 13 divided by the square root of 38. So let me go back here. 13 divided by the square root of 38. And I need to divide here. And you can do this on another calculator. You just don't, you want to get the answer first. Let's see, 13 divided by the square root of 38. So, okay, so we get 0.94, and we're going to round that to 2 decimal places. So we are going to put 0.95. So that is our test statistic that we're going to test. Now, the next thing we have to do is get our critical score. So to get our critical score, we need to go look it up. Actually, I'm going to show you how to get it. So alpha is, we need to write out what alpha is. So alpha is 0.10. So alpha is 0.10, and it's a one-tailed test. So what you can do is you can look in your book or on the PowerPoint. So if I go to my book on page 344 and I look up the Z-score, critical Z-score, where, let me move out of the way. If you see Z 0.10, you can see the Z value is 1.28. It's the first one right here. Okay, so our critical value for Z, and I want to double check this just to make sure, 0.10, and then over here, if we go to 0.10, which is the first one, it's 1.28. So our critical value is 1.28. And our test statistic, 0.95, would be somewhere below 1.28. Okay, so if it's in our critical, if it's in this area over here, we would reject it. But since our test statistic 0.95 is over here, we fail to reject it, or we do not reject it. Okay, so our test statistic, we got 0.95. That was the formula. The critical Z-score, the 1.28, that was in your book, and you can write those critical Z-scores down to help you. And because our test statistic was less than the critical value, we do not reject the null. Now, the p-value here, the way you could find your p-value is use Excel, and you're going to do equals normal. This is a normal distribution. Normal, standard normal distribution, okay? Our Z value, you're going to use the test statistic because the p-value is the probability of it being as extreme as the test statistic. So since our area is over here, okay, we want the greater than side, and when we're doing p-value, we want to use our test statistic. So greater than 0.95. So Z is going to be 0.95, and we want it up to 0.95, but that number is our less than side. So to get the greater than side, you're going to say 1 minus that. So we will get 0.171 for our p-value. 0.171. So take your time on this. Walk yourself through the steps. Use your formula. Watch this video and work it. Work your problem after you practice working this problem. And I'm going to do another one in the next video. In question 4, I'm going to do a 2-tailed test. But this was question 3 and this was a 1-tailed test. Let me know if you have any questions.